right, Unit 2, Section 2, Compound Statements and Truth Values. At the end of this, you should be able to write a compound statement and determine its truth value and of the compound statement. A statement, so here we are right here, is a sentence that is either true or false. This is called the truth value, whether it is true or not true, false. This is represented by using letters such as P or Q. Those are the typical letters that you use in logic statements. You just P's and Q's. And so if you've ever heard the phrase mind your P's and Q's, this is it. Your truths and your false, your this to that type statements. But you could use any letter that you wanted to, because if you have more than two sentences, you might have to use more letters. So you might use a letter that represents the sentence. So like here's an example. A statement is P, and the statement P represents supplementary angles have a sum of 180. I might use an S for that because it's about supplementary. But we picked P, so we're going to use P. It's almost like a variable. It's just a representation of something. Okay? But this one's truth value, supplementary angles have a sum of 180, is true because the definition of supplementary angles are angles that have a sum of 180. Now, a negation, okay, is a statement that has the opposite truth value. It is shown by the symbol, and this is called the tilde, this little squiggly line. There's one on your computer, okay? It's called a tilde, but it's a little squiggle in front. Put that out here, tilde. The tilde is in the upper left-hand corner of your keyboard, and it is right below the escape button. And that is the symbol used for not. So if we say tilde P, or we say not P, that's how we read that little symbol in logic, the supplementary angles do not have a sum of 180. Basically, you plug a not into the statement that was before. If the statement already is a not statement, you do a not, and that's just like negative, negative, and you get positive. So supplementary angles do not have a sum of 180. Well, that's actually false, because they do have a sum of 180. That is the definition of supplementary. Compound statements. When you compound things, you put things together. So it's two or more statements forgot the E, joined by the words, and you might know this from English class, but and or. This is a compound statement, linking words, okay? There are symbols for these, and there are definitions for these. A conjunction, okay, a conjunction is a statement joined by the word and. It is written as A and P in symbol form, where that little kind of upside down V, you can kind of think of it that it's like the A of and. Okay? So when, when both statements are true is when a compound or a conjunction, use the word and, is true. They both have to be true. So if we say this and that, both the this and the that have to be true. If we say P and Q, P has to be true and Q has to be true for the whole thing to be true. If one part's false, the whole thing is false. A disjunction is a statement joined by the word or, and it is written as P or Q. And here's how I came up to remember that, all right? Whenever you're like, Let's see, we'll put a little guy here. He's got an arm. He's got another arm. There's his neck. Like, ding, ding. There's my little guy. And it's like, what do you want for dinner? Do you want this steaming pile of stuff, or do you want that? So if you want this or that, it ends up making this little shape out of his arms there. I don't know, this or that. And it makes a V. And so you can remember that that goes with or. It is true when at least, I don't know why I put an E in there, one statement is true. They don't both have to be true, just one of them. So if it's P or Q and P happens to be true, the whole disjunction is true. If Q happens to be true, the whole disjunction is true. If both are true, the whole thing's true. But if neither are true, then it is false. Okay? So let's look at some examples. Now remember, this conjunction and disjunction. Like the dis, I think of dis or dat. And the conjunction is they're conjoined, they're stuck together. They can't be separated. The disjunction, dis or that, I can do either or both. Okay? So let's look at an example. Given the statements below, write compound statements. Then determine their truth value. Okay, so P represents there are 7 days in a week. Q represents March has 30 days. And R represents Halloween is on October 31st. I would have used H for Halloween, but okay. We just have to remember what the symbols mean. So this is P, and if we go back up and look at which one, okay, the one that looks like an A is and. P and Q. So we're going to say there are 7 days in a week. That's a weed. In a week. And we do Q. March has 30 days. Well, if we try to determine the truth value of that compound statement, that conjunction, we have to look at both pieces. So let's look at P. There are 7 days in a week. Well, a week is 7 days long. So that is a true statement. March has 30 days. No, that's actually 31. So, I don't know why I put 31. That's actually false because March is 31 days. And Halloween is October 31st. That is a true statement. That's when we celebrate Halloween. So if we look at this P and this Q, we have a true and we have a false, and they have to both be true with and, so the truth value of the whole conjunction is false. Now let's look at Q and R. Let's plug them together. So March has 30 days. And that symbol is still and. And then we do Halloween is on October 31st. Now, the Q part, remember, is false, but the R part is a true, so the whole thing together is false. Now, P then R. There are 7 days in a week. And Halloween is October 31st. Well, there are 7 days in a week, and Halloween is October 31st. They're both true, and it's an and, so it is true. With and, they both have to be true, so we want to make sure that they are. Let's keep looking. Ooh, here's an interesting one. Not P and Q. So there are not 7 days in a week. And that's the and, right? Yep. And I need you. All the way. March has 30 days. My March looks a little weird. Okay. Well, let's see. Not P. There are not 7 days in a week. Well, actually there are, so that's false. The Q, March has 30 days. That is actually false. They're both false, which makes the whole thing definitely false. All right, P, now the symbol switched, it's upside down. Now it's P or R. So there are 7 days in a week. Or Halloween is on October 31st. Well, this is an or statement. And when we deal with or statements, either has to be true, but not both. So if we look at the P, 7 days in a week, there are 7 days in a week. R, Halloween is October. It is. They're both true. So that really makes that one true. You only need one in an or. Okay. Number 6, not Q, then R. Let's go back and look at what Q was. Q was 30 days. Okay, so March does not have, because haven't wouldn't be right, have not. March does not have 30 days. Or, and what's R? Halloween is on October 3rd, 31st. We need at least one of those to be true. So March does not have 30 days. Well, it does have 30 days. Well, and even that one is kind of an interesting one. March has 30 days. It does have 30 days. In fact, it has 31 days. So it definitely has 30 days if it has 31. So maybe we could have said that's a true statement. But I think they're saying the total number of days. March does not have 30 days, which is true. Or Halloween is on October 31st, which is also true, which makes both of them true. Since both are true and we only needed one, bam, the whole thing's true. Not P or not R. Okay. There are not 7 days in a week. Or Halloween is not on October 31st. There are not 7 days in a week is false, because there are 7 days in a week. Halloween is not on October 31st is also false. We didn't get even one true, so the whole thing is false. Not P, then not Q. There are not 7 days in a week. Or, let's see what Q was again. March does not have 30 days. March does not have 30 days. Okay, well, there are not 7 days in a week is false. March does not have 30 days is true because it has 31 days is what we're going to say. I mean, it has 30 because if you have 31, if you got $31, you got $30. But we'll get out of that little logic puzzle there. But March does not have 30 days is true. And if one of them is true, then the whole thing is true. And that's what we're talking about when we talk about compound statements and conjunctions with and disjunctions with or. Now, go ahead and write your own statements and determine the truth value. Write them into these different pieces, P or R, not P or Q, not P and R, not Q and R, P and not R, not P or not Q, not R and Q, and see what their truth value is. What we did in class is we tried it and we wrote them, and then we had a friend or a partner figure out if they were true or not. So you can try that with your mom or dad at home if you want to. But that is truth values and compound statements.